Hello and welcome, this is Vincent with Central Tutors, and today we're going to be learning about significant figures. So, significant figures are essentially the degree of accuracy you report a number to. This is important because in science, we often want to specify the precision depending on our needs, and we don't want to carry around unnecessarily long numbers. So, I'll give you a quick example. Say we wanted to calculate the area of a circle. For our purposes, using pi 3.14 would be perfectly acceptable. But people at NASA need to use pi to way more significant figures. They actually use 15 because they need to be way more precise. But for our purposes, using 15 significant figures would just be a waste of time. So that's just a quick example, but we're going to get into some more concrete examples to get a bit of practice in just a second. So over here we have our rules for significant figures, and we're going to try and apply these to these numbers over here to gain a bit of practice. So let's get started. For our first number, from our first rule, we know non-zero digits are always significant. So 2, 8, and 4 are all non-zero numbers, and so these are three significant figures. And these two zeros over here are called trailing zeros, and they're only significant when there's a decimal point, and there isn't here. So these aren't significant, and this number is given to three significant figures. Now for our second number, let's use our first rule again. We know 3, 4, and 1 are significant, and actually this 0 in between the 3 and 4 is significant too, because of our second rule. We need to remember zeros between non-zero digits are significant. So these four numbers are significant here, and that means our overall number is given to four significant figures. Now on to the next. Over here we have some leading zeros. These are zeros in front of the number. And from our third rule, we know that they're not significant. So all we need to apply is our first rule, and we just have that 3 and 1 are our significant figures. So this number is given to 2 SF. Now last one, this one's a bit of a trick because there's a decimal point. And even though we only have one non-zero number, because we've added the decimal point, it's telling us that trailing zeros are significant. So this number is actually given to 4 significant figures. This time, I'd like for you to pause the video and to try and attempt to figure out how many significant figures these numbers are given to. Once you've given that a go, unpause the video and we'll go through it together. Okay, so first we have 18.40. So we're going to need to apply our first and our fourth rule. First of all, non-zero digits are always significant, so our 1, our 8, and our 4 are significant. But from our fourth rule, trailing zeros are significant if there's a decimal point. So this 0 is also significant, and this number is given to 4 significant figures. Now next we have 0.032, and we know that leading zeros are not significant, so these first two zeros are not significant. But from our first rule, non-zero digits as usual are significant, so the 3 and 2 are significant, so overall this number is given to 2 significant figures. Now, next up, we need to apply rules 1 and 2. We know that non-zero units are always significant, so our 1 and our 8 are significant. And zeros in between non-zero digits are significant too, so is this 0. And lastly, these two zeros over here are not significant, because they're trailing zeros, and there is no decimal point in this case. So 1, 0, and 8 are significant, and that makes 3 significant figures. And now lastly, we have 416. And this one's straightforward enough. We just need to apply our first rule. Non-zero digits are significant, and that's all we have in this case. We have 4, 1, and 6, and that makes 3 significant figures. Thank you for joining me in this Central Tutors tutorial. Hopefully you found that useful. And if you need any help with any more math videos, please follow the link in the description for more tutorials.